today I will give you, the introduction to the WaveJudge 5000, which is the latest product in the Keysight portfolio. And the objective today is to give you a high-level overview so that at the end of the session you'll understand, what is the WaveJudge, how it's used, what are the various applications and different technologies that we support and cover. I'm going to do that by showing a few PowerPoint slides. I really don't like PowerPoint too much, so I'm going to try to limit the number of PowerPoint slides and try to use the actual GUI. What you're looking at now is the actual WaveJudge GUI. So you'll see me bouncing back and forth between these two in order to give you an overview of the WaveJudge 5000 capability. So what is the WaveJudge 5000? The WaveJudge 5000 is essentially an RF sniffer which supports both 4G and 5G technologies. It is a very small one rack unit high chassis, and it has 4 plug-in modules. So it's modular, so it can change its interface to either 4G or 5G, and it's controlled with a Windows PC. The Windows PC actually has 2 functions. Number one, it will control the RF sniffer capability of the hardware. So the Windows PC will actually control the collections, the RF collections in the capture of the RF signal. But it can also be used. We have some applications where the WaveJudge is used as an IQ import analysis screen, so without the usage of the WaveJudge hardware. So that's also a possibility, is to use the WaveJudge software application without the WaveJudge hardware to analyze IQ files. And I'll discuss that shortly about where that may be helpful and useful. So by the end of the session today, hopefully you'll realize how this tool can be helpful in the defense modernization space, 5G.mil space, and I'm going to try to highlight some other applications in the defense and aerospace market that this tool is used for today. 4G, 5G capture device is, we cover the full 3GPP spectrum. So here you can see that the 3GPP release 13, 14, 15, 16 all supported today. Release 17 is in beta, not available today, but when the 3GPP standard is finalized, we will support that as well. So today the WaveJudge is supporting all of the 3GPP capability and technology. Same on the 5G side. On 5G NR, we support standalone, non-standalone, all of the numerologies, all of the bandwidths, et cetera, et cetera. And there are a few other technologies here that we support as well. For example, Wi-Fi, Multifier, and WiMAX, but we won't talk about those today. So today I'm going to focus mainly on the 4G, 5G collection capture capability. Then this gives you an idea of exactly what the WaveJudge is performing. On the left side, we see 4G or 5G base stations. For example, we have a G node B. This could also be an E node B. Small cells or ORAN as well. The WaveJudge supports ORAN RF collections. So here I'm showing you an ORU. And this could also be a simulated base station. Whenever I visit some of the labs, there are UEs that are being tested, which are on the right-hand side here. And in that application, you may use a base station simulator. So here it can also be a Keysight UXM. So the point is that any one of these base station devices, 4G, 5G, small cells, all of those can be used for WaveJudge collections. So what we're really showing here is the versatility of the WaveJudge. The WaveJudge is really for future networks, right? The perfect space for the defense modernization and the 5G MIL applications. On the right-hand side, we show the UEs, and what's important here is that the WaveJudge is a multi-UE device, okay? So it will capture information from a single UE if it's there, or multiple UEs. For example, if you take the WaveJudge out in the field, and the WaveJudge will find all of the users in a particular sector. And we're doing a lot of work today in the military space with DISA, because today DISA takes the WaveJudge to the field and they do RF collections, and they're looking for particular messages, particular protocols on that sector or cell to understand how many users are there. What are those users doing? Are they rogue users? Okay, so again, we'll talk a little bit about that more whenever I show you the WaveJudge GUI. But also it can be a simulated UE as well. So if there's also a lab, for example, MITRE, we are working very closely with the MITRE lab. They may have a real G node B, and in that application they might use a simulated UE. So the real point here is that the versatility of the WaveJudge allows you to capture RF signals from real base stations, 4G, 5G, O-RAN, or simulated base stations. And the WaveJudge also captures information from real UEs or simulated UEs, and that can be for a single base station test or multiple base station test, as well as a single UE or multiple UE, or hundreds of UEs. For example, if the Keysight UE simulator is simulating 400 UEs, the WaveJudge will capture and decode and give you analysis for all of that traffic. So here I have a depiction of multiple downlinks and multiple uplinks. And what that is indicating is MIMO schemes. For example, if the base station is sending 2 downlinks for 2x2 MIMO, the WaveJudge will capture both of those downlinks, 4x4 MIMO, 8x8, etc., and the same in the uplink. So the WaveJudge does not have a limitation about MIMO number of MIMO layers. So once the WaveJudge does the RF collection, all of that information is sent to the PC for analysis. Okay, and there's 2 very distinct types of analysis the WaveJudge will provide. Number 1 is the RF and PHY layer analysis, which you see on the right-hand side of the GUI here. It's almost similar to a VSA. We have some overlap with VSA capability, but the WaveJudge provides more layer 1 physical layer capability more than a VSA, and I'll show you that very shortly. What some of the differences are there. Also, the WaveJudge will give you layer 1 through 4 protocol analysis, and you see that here in the middle part of the window. Okay, so we will decode all the protocols, layer 1, 2, 3, 4, for both 4G and 5G protocol stack. Okay, so that's a general overview. Capture the RF signal on the downlink, capture the RF signal on the uplink, process the information, and provide 2 distinct types of analysis. WaveJudge can do that in a cabled environment in a lab. There are a lot of government-type labs that we are working with today. And when you are in that environment, typically we see a cable between the base station and the UE. And in the lab environment, it's very easy to add the WaveJudge into that test bed with a 1x2 splitter. So on the downlink, you have 1 input and 2 outputs, and the WaveJudge will capture the RF signal. But the important part of that is you'll notice the WaveJudge is not in line with the RF signal. So for example, on the downlink, and when you're in a lab environment, the downlink passes through this splitter and it transmits onto the UEs, and the RF signal does not pass through the WaveJudge. So the WaveJudge doesn't change the RF signal. We don't alter the signal in any way. We're just capturing and giving you the analysis of what's happening in the downlink, and the same in the uplink. On the uplink path, the exact same technology holds. What that means is, we are not changing the uplink whatsoever. Okay, so that's kind of the high-level overview, downlink and the uplink. We can also operate, as I mentioned earlier, in the field over the air with antennas, and we can see that here. So if anybody would take the WaveJudge out into the field in a van, we have a small footprint. There would be, for example, a downlink antenna. There would also be an uplink antenna, and everything I've mentioned so far is exactly identical to being in a lab environment. So going out to the field, doing an RF collection, storing the analysis or storing the information on a PC, and then doing another collection is a typical application that we see for some of the folks at DISA, right? They'll do collection at a location, they'll move to a new location, do a new collection, and they'll come back to the office with a handful, 10 or 15 or 20 collections to do the analysis. So the WaveJudge also supports that as well, where you do the collection, storage, save, and then we can open up those files later without having to use the hardware. We can open them up later and do the analysis windows. So here again, we show more about some of the VSA capability, the protocol capability, full protocol stack. We show, layer 1, 2, 3, 4, and the support capability of the WaveJudge, as I mentioned earlier, is full 3GPP for both 4G and 5G. So yes, we support TDD and FDD, very important today for 5G, right? In the 5G.mil space, TDD is becoming very important. And if you were involved in the 4G space, it was mainly FDD in the US. So a lot of FDD activity in the past, 4G, but as the new modernization happens and the 5G networks are rolled out, TDD is very important, and we support both. Same with the channel bandwidths, right? With this channel bandwidth, it's very important today to support high channel bandwidths, 100 megahertz or 8 times 100 megahertz to get 800 megahertz, and this WaveJudge supports that right out of the box. All of the frequency bands are supported, sub-6, millimeter wave, FR1, FR2, no problem. All of the MIMO schemes, 8 carriers, as I mentioned earlier, all of the 3GPP releases, standalone, non-standalone, all the numeric, pretty much everything. But the point of this slide is that we really do support anything you'll find in the 4G, 5G space out in the field or in a lab in order to do RF collections as well as analysis on those networks. Another interesting thing is that the WaveJudge can be combined for NSA support. So here what I'm showing you is that we have a few WaveJudge chassis here, which would be a capture for 4G as an example, and then a few of the chassis on the top may be a 5G collection. But when you combine them together, it will support 5G NSA. What that means is when the UE is joining the network, the UE will join the network on the 4G side, and the WaveJudge will capture all the information downlink and uplink for that UE joining the 4G network. However, it will immediately, I believe it's within 70 milliseconds, move to the 5G network, and the WaveJudge will capture that protocol messaging, which actually moves the UE from the 4G to the 5G network. So the interesting thing here is we see the UE attach on the 4G side, but we also see all the protocols that gives the instructions to the UE to move to the 5G network. And then the WaveJudge will be, of course, capturing the 5G side. So it's a full 5G NSA capture of both the 4G and 5G side in one kind of concise system and one GUI. All of that information will exist on one GUI. It's not on 2 different GUI screens. It's not 2 different tools. This system is really just treated as one large, WaveJudge system to do all those collections. One last application I'll mention before I switch over to the GUI is that when the WaveJudge is decoding the protocol side, we can even support the decode of ciphered messages. This is very important, especially in some of the defense applications we work with today. What that means is whenever the message is ciphered, the WaveJudge, we have a capability of how we can actually capture the cipher key and decode that message to give you the protocol analysis for those ciphered messages. And that product is called the Cipher Judge. It's a very small hardware device. You see it here. It has a very small footprint. It's not much different in size than an iPhone. And the way it works is you must have the phone or the UE in your possession. So if you have the UE in your possession, you remove the SIM card and you insert the SIM card into the Cipher Judge device. And the Cipher Judge has a cable that will be plugged into that SIM slot. So the SIM slot of the UE will be empty because the SIM card has been inserted into the Cipher Judge. So the cable plugging into the UE allows the Cipher Judge to capture the communication between the phone and the SIM card, because when you turn the phone on, all of that communication will now be passing through the Cipher Judge device. The Cipher Judge device will intercept the cipher keys. So this is the way we actually capture the keys, the key sniffer. And those keys are automatically transferred to the WaveJudge PC, and that allows the WaveJudge software package to automatically decode all of the messages, including ciphered messages. Very, very powerful tool, especially if you'd like to go, again, out into the field, do any kind of work on a real live commercial network. So it is not necessary to do this testing in cooperation with the operator. So if you would like to go do a collection, for example, the DISA guys, they have a Defense Spectrum Organization, the DSO. They're trying to look at some of the spectrum that they've given up to the commercial space. So what they do is they go out in the field. They're actually capturing real live traffic from Verizon, AT&T, and they're using the Cipher Judge, and they can decode everything happening on that particular user, and they can do a lot of good testing and figuring out what's happening on that particular spectrum at that particular location. So there's a lot of collection activity happening around this space using the Cipher Judge. The WaveJudge also helps to go out into the field and look at rogue devices. Another application is for denial of service attacks. We found that there's some research happening today where the 4G and 5G networks are not as secure as they should be based on some of the research. And there is a researcher who has done some analysis where they programmed a UE, they programmed a phone to flood the network with a UE attach message. So it's almost like the old denial of service back in the old Ethernet days, right? It's kind of like a 4G, 5G denial of service attack, where the UE transmits a RATCH message hundreds or thousands of times, and the base station, when it receives that RATCH message, it has to process that RATCH message in order to determine whether to allow that user onto the network. But as the rogue device continues to flood the network with RATCH messages, what it does is it really floods the base station processor, and we've seen some cases where the network actually either crashes or really stops allowing other users, or there's a big network problem there whenever that happens. So you'll see all that kind of information on the WaveJudge, and again, it's without having to coordinate with the service provider. You can go do a collection. You can cause some of these floods, or you can do it in a lab environment. Probably better to do that in a lab environment. And on the WaveJudge protocol window, we're going to see all this data and all this information. Okay, so let me switch over to the WaveJudge GUI and give you an idea of how do we actually do this. So as I've mentioned before, the WaveJudge GUI has two windows. On the right-hand side, we have some layer 1 PHY analysis, and in the middle of the window, we have protocol analyzer. And the protocol analyzer will give you analysis for layers 1, 2, 3, 4. And we will control which layers you would like to view based on some checkoff boxes. So another very nice feature of the WaveJudge is that if you're only interested in a higher layer protocol, for example, you'd like to see the UE attach, you want to see the UE moving from the 4G network over to the 5G network, what I will do is I will turn off all of those lower layer protocols and only show the upper layer RRC and NAS protocols. However, if you're interested to see layer 1 transport blocks, we will show all of the physical channels. So if there's a test you're doing which involves looking at PDSCH or control channels, PDCCH, et cetera, we can expose those protocols. One of the applications, again, that the DISA Defense Spectrum Organization is doing is they're going to the field to do some collections and analyze how many users are in this particular sector. And they create a baseline. So there may be a baseline of a particular area, maybe around the U.S. Capitol building, of what the typical day, how many users are typically in this area, and then they may do a collection to try to see if that changes. For example, if there's a doubling of the number of users in this area, that may alert them to something happening. And the way they're doing that is they're actually monitoring DCIs. So we can hide all of the protocols and only show DCIs, do a collection in a particular area, and all those DCIs are going to show you the users. We're going to show you the RNTI or the UE identity, the IMSI, and store the collection. And then you can do a collection again later in time and compare that to how many DCIs, for example, we found here at a previous time. So again, the point about the protocol analyzer is we have all of those protocols available, and the user can hide or expose only the particular protocols that you're interested in on a particular test. Okay? So once we determine which protocols we're interested in, you'll notice that we have protocols here for both the uplink and the downlink. As I mentioned earlier, all the protocols will be here for 4G and 5G as well. So all in one nice, concise GUI window, we can see the protocols in time, almost like a ladder diagram, and we can see that let me also turn on the RATCH messages. Okay? So here we can see that the user sent a RATCH, and then the base station sent a random access response down, and then the user uplink. So it's a very nice protocol structure of a UE attach. In addition to showing you the protocols, we also have a lot of KPIs along with each message, right? So for each message, we can understand which user is sending the message or which user is receiving the message, the power of the message, signal-to-noise ratio, EVM, MCS. There's an awful lot of KPI information that we can give for each message, along with the real protocol decode. So when I double-click it, you'll see the entire message is decoded, every bit, every byte, and we show the English translation on the top, so you can see all the different rank indicators, CQI index, ACK, or on the bottom we show the bits and the bytes if you're interested to go down to that kind of a level. Okay. One of the very powerful features of the WaveJudge software is that the user doesn't need to be an expert on 4G or 5G protocol. And what that means is the WaveJudge has an error checking column, so we do the checking for you. And it is more than just a protocol check. What we do is, for example, on layer 1 messages, if we're looking at transport blocks, we will also do CRC error checks. And if something is wrong, you'll see it's in red. So it's very easy to do a collection and just scroll through, find some errors, and the WaveJudge will tell you, pinpoint to you exactly maybe where to go to try to find out what's happening on this network. For example, if there's a layer 1 error, CRC error, we'll see it here. Okay, let me remove that again. If there's a protocol error, we'll see protocol errors. But one of the very powerful features of the WaveJudge is we also do things like what should be transmitted over the air, which was not transmitted over the air. And what that means is, because the WaveJudge sees both the downlink and the uplink, right? The WaveJudge is receiving both downlink and the uplink. It's very different than an endpoint. It's very different than, for example, a drive test tool or a log. It's different than looking at the base station log or the UE log, because they only get one of the directions of the transmission. Because the WaveJudge is in the middle, we see both downlink and the uplink. That gives us a lot of power to do things like monitor DCI format zeros. And when we see that, we know that there should be an uplink transmission coming 4 milliseconds later, right? This DCI format 0 is telling the user to transmit an uplink message. So the WaveJudge will enter the PUSCH in the window even if we don't receive the uplink message from the user. So what that means is we will show you messages in this window that were supposed to be transmitted, and if they are transmitted, we're going to call it OK. If they're not transmitted, or if they're transmitted in the wrong frequency or time slot, we're going to show you an error message here. Okay. So just trying to give you a feel for, some of the ways we can use this protocol list to look at various protocols that you're interested in, look at the error check, find exactly what you're looking for, maybe DCIs, maybe some other information, double-click it to find the exact protocol messages, and then maybe store some information and use some of these collections at a later point in time for exactly what you're trying to determine. Okay, hope that all makes sense. Let me show you very quickly the right-hand side, some of the VSA measurements, and then I'm going to wrap it up. Hopefully this will only be maybe 5 or 10 more minutes. But one thing to notice is these two windows are actually connected and correlated together. So there's a correlation between the protocol list and the layer 1 RF analysis. What it means is whenever you go through and click on a message, you'll notice some of these charts and graphs are moving because we show you the location of that message, for example, in the time domain. So if I show you a time domain chart, you can scroll down to the list, click on a message, and you'll know exactly the location of that message. We can then use the tools, some of the tools we have at the top, to zoom in on that message and see exactly what is the profile of that particular message. Okay? Let me show you how that can be useful. Right now, I'm showing, this is an uplink, so this is showing me the WaveJudge uplink RF collection, and the x-axis is time, and the y-axis is power. So I can see very easily that there was some uplink activity here. It was quiet, and then there was a burst of uplink. Quiet, a burst of uplink. These may be RATCH messages. There may be a user who's sending RATCH periodically to try to join the network. And again, we can zoom in on these exact little bursts, show you exactly what the message is, and do a measurement as well. So you can even measure, if you're interested, what was the noise floor and what was the power level. This is 63 dB of this exact message. Okay, so how do we use this? How does the WaveJudge help you use this? Well, one of the things we're seeing today is the changeover from 4G to 5G is much more complex than some have thought. And one of the applications or one of the problems that's happening is 5G has a lot of TDD networks out there, and it's much more important for the downlink timing to be correlated or synchronized, I should say, with the uplink timing, because those downlinks and uplinks on a TDD network are sharing the same time, sharing the same frequency. So they're at one point in time the downlink transmits, then another point in time the downlink stops, and the uplink transmits on that exact same frequency. So it'll be very important to look at some of the relationships between that downlink and uplink timing. So give you an example of how the WaveJudge can help to do that. I'm going to click on an uplink message. So here's an uplink message. So the time domain power chart shows me the exact location of that message. So I can kind of zero in on that uplink message. And what the WaveJudge tells me is that message should start on the green line. So this RATCH is supposed to start on the green line, and it's supposed to end on the red line. But we can even zoom to a much more detailed level and show you that the actual signal, which is the blue line, is starting too late. Okay, so we can see that the the uplink message, the user, the UE, should be starting its uplink transmission here, but it's not starting until way out in this area. And we can use our red marker to put a marker on the red and actually give you a measurement of that. Okay, so if you're doing a test for a particular UE, you can talk to the UE vendor and say, your UE is sending, whenever you're moving to 5G, the UE for TDD as an example, may be causing a problem because now that the uplink is starting too late, it may be stepping on the downlink time slot where the downlink should be transmitting, and you can even see that that's how many, it's 88 samples too late. Okay, so that's one kind of an application of how we would use the time domain power. I will show you now the 2D power, and then I will stop, and because I like to show the 2D power because I think that's one of the most powerful ones we have. So if I zoom in a bit, just to show you what this 2D power gives you, the x-axis again is time, and the y-axis is reference as a resource elements. Okay, we know in the 4G space, 12 resource elements is a resource block. But the WaveJudge is showing you more detail than a resource block. We're actually showing you the individual resource elements. And we have a little color-coded chart to tell you exactly what you're looking at. So we can see the red ones are the reference signals. Green would be a downlink transmission, a PDSCH. We can see the PSS and the SSS, et cetera, et cetera. So we're showing you the full resource block map of what should be happening in the downlink and what should be happening in the uplink. We can do both. And remember I mentioned earlier that these two windows are connected together, so you can even choose one of our protocols on the left-hand side window. For example, this PDSCH, maybe I'm interested to look at this PDSCH in the resource block map, and when I click on it, this little red tick mark will move to show me the exact location of that PDSCH, so I can see it here. So once again, it's very easy to choose a protocol and see the exact characteristics of that protocol in the 2D power window. So when I click on it, I can see that this PDSCH looks like it's 4 resource blocks that are non-contiguous, so they're separated in frequency, and they're all in the downlink slot 5 on frame 874. If I click away, you'll see they're actually green. And as I mentioned earlier, WaveJudge, the WaveJudge window can zoom in to a very, very fine detail level, and we can see what some of these assignments are. So here's my PDCCH, here's my PDSCH reference signal. So these are all of the assignments of where the transmission should be, and in order to see whether there's actually energy there, and this is the cool thing here, is the WaveJudge will overlay on top of this resource block map the actual energy of the resource elements. And whenever we turn on the power measurement, the resource element will turn white if there's power there. So what it means is the WaveJudge captured this PDSCH. We knew that the location of the PDSCH in the time frequency space should be here, the green block, and it actually was there because all of those blocks are highlighted in white. They're actually gray, and we can show you that the power of that received PDSCH is 65 dB. The power of the reference signal is 12 dB higher, right? It's minus 52. This is minus 65. And this also shows interference. We can see very easily some of the resource elements don't have an assignment. There should be no transmission in some of these resource elements, but there's actually some transmission here. So we can even show, where interference may exist, et cetera, et cetera. So one last thing to show before I disconnect is I'm going to move this to the uplink. Okay, so I mentioned earlier we can show you this for both the downlink and the uplink. So if I move to an uplink message, I will click on the PUSCH, find this one, and here you'll see the PUSCH uplink message. I'm going to turn off that power measurement. Okay, and this PUSCH is the yellow one. So I once again zoom and let's see exactly what's happening with this PUSCH. So here's my PUSCH and here's DMRS. Once again, a lot of activity happening in DMRS in the 5G space. Now let's overlay the power here, and the uplink doesn't look as good as the downlink, right? Remember in the downlink, everything looked pretty good. I saw some interference, but on the uplink, you can actually see some devices sending uplink at different power levels for each resource element. So this particular UE, if you're doing a test on a UE to do maybe an interoperability test, is the UE operating properly? This is not a very good UE because one particular UE is transmitting minus 90 dB in one resource element and minus 111 in the other resource, I would suggest that this resource element isn't even being used. So probably there's going to be a performance hit here. If you want to look at the performance of some networks, why is a 5G network not performing? One of the reasons may be very simply that the UE, the user, is not using all of the spectrum that's been given to it. And here you can also see there's a lot more interference here on the uplink side than we saw on the downlink side. Okay, so I think that's about it. I'm going to wrap it up here. I hope that you can see that the WaveJudge can definitely help in the defense modernization space, 5G.mil, things like the DISA DSO collection out in the field to find rogue users or how many users are in a particular sector or spectrum. And if you have any questions or you would like more information, please contact Sanjole at keysight.com and somebody will be in contact with you immediately. So thank you very much, and I hope you enjoyed the session.